I am especially pleased to welcome Alison Moynihan to give this presentation because Alison is one of our own. Alison graduated from the program with a master's in sustainable building a few years back, and since then she has become a certified passive house consultant and is employed by Foard Panel, where she serves multiple duties as project manager, energy consultant, and structural designer. She's combining her passions and expertise for performance within the context of panelized construction. She's especially qualified in speaking about finding practical and sustainable solutions for building design problems within the structural insulated panel industry. So with that, please welcome Ms. Moynihan.
So much bigger crowd than I was expecting. So we'll see how well this goes. As Carl mentioned, I had worked for a structural insulated panel manufacturer basically since I graduated, which means most of the stuff that I'm talking about is either directly related to that or it's stuff that I've gleaned from other people I worked with competitors that I bid against, and then conferences and other stuff that I've done to educate myself since leaving. So a lot of this is secondhand, but that's kind of the way all stuff is learned secondhand from somebody else. So we'll see how well I can pass it on. So we're going to start with some definitions. Prefabricated is kind of the general term that I'm going to use interchangeably with other things. We have a lot of parts of the building industry that are already prefabricated, notably windows. Pretty much nobody makes those on site anymore. Appliances and furniture also. But I'm actually going to specifically talking about prefabricated buildings, building them off site. So the first and most common still of the prefabricated homes are the mobile homes, which are basically small enough that they can be driven on the road. Currently, that means about 60 feet long, 14 feet wide, and 13 foot 6 from the road, which actually means only about 10 and a half, 11 feet of building, which is a very awkward proportion and often too small for many people's tastes. They are also on often semi-permanent or not permanent at all foundations, and they have different code requirements, structural or otherwise, than a full site-built house. Some of that is disappearing in newer versions of the code, but for a long time, mobile homes did not have to be built to the same standards in terms of they basically didn't care if they got destroyed after 20 years instead of after 100 years. So they are a little different. Everybody looks at mobile homes and they think small, ugly. So people started saying, okay, well, we want them to be a little bigger, a little more flexible in the design. And that's where they came up with modulars, which are basically mobile homes broken up into pieces so you can make a bigger or more interesting design. They still have, each piece has to be designed so it can be transported over road. They can be stock plans or they can be customized for each job. They can be usually they include some utilities and some finishes, but they can be just stick-built pieces as well. And they have to be designed both to be transported and to be on site, which means, as you can see in the pieces, there is bracing on that piece of roof that's being lifted up that wouldn't need to be there if they were building this in site, because they wouldn't need that open part of the wall to be supported. So there are things that you have to do if you're transporting it that you don't have to do if it's being built on site. And then the last section is panelized, which is basically not shipping empty space. So now instead of building pieces that are road-sized volumes, you're shipping everything as flat surfaces. It limits how much of the utilities and the finish work you can actually do, because obviously utilities have to be connected to each other or they don't work. And by utilities, I'm talking about water, electric, air, all the things that make a house warm in the winter and livable. So all sorts of different kinds of panelized construction out there. So subcategories of panelized. I am most familiar with the structural insulated panels, which are also called stress skins panels. They're a different structural system entirely than many others, so that's why they're a separate category. There's also curtain wall panels, which are perhaps the oldest panelized system because most skyscrapers have been using curtain wall window systems for quite some time now, where they prefabricate whole sections of the wall and put it up. There's also prefabricated concrete, pretty common in commercial work. It's also really common in bridges. I'm sure most of you have seen giant pieces of bridges going down the road. And it's a lot easier to do it that way than to build the bridge over the water. So there's a good reason for that. Then there's prefabricated stick-built walls, which is the most common version of prefabricated or panelized walls. And it can be pretty much anything. Anything you could build on site, you could also build panelized, mostly. But there are all sorts of different levels that you can build a stick-built prefabricated wall. You can just do the studs, you can do the insulation, you can add the windows, you can do all the finish work, you can even do some of the electrical and some of the plumbing. So, brings us to this whole spectrum idea. There is all sorts of places to be on the prefabrication level. And a lot of what we're deciding is how much should we prefabricate before it stops being better? What parts of it do you want to prefabricate? What parts are easier to do off-site? What parts are cheaper? And the answer is it's not the same for every site, and it's not the same for every job. This is really important to remember. Good, fast, and cheap. That's what everybody wants. Unfortunately, you don't generally get all three. You get to choose one, two of those, and you can balance, I want it to be better, but I'm not as worried about it how cheap it is, or I want it to be really fast and really good, but I'm going to spend a lot of money to get that. And the idea of the prefabrication making this triangle go away, I don't think so, but we're hoping it'll work a little bit. So, first is cheaper. Biggest thing, use less material. Build more small or at least less surface area buildings. And then if you can see there's that giant waste bin in front of that building in the middle. Construction waste is a big reason that people choose modular or panelized is they don't want to have a lot of construction waste. Then another way to make it cheaper is bulk pricing. Everybody knows if you go to BJ's and buy the giant bag, it's cheaper than if you buy the little one from the co-op. But that only works if you can eat all of that before it goes bad. The same thing works with buildings. You can buy bulk pricing on larger quantities of materials, but if you can't use it or if you then have to ship it from this site to that site to that site, it stops being cheaper. So bulk pricing can work, but not always. And then there's material quality. High quality material costs more, low quality generally doesn't cost as much, but usually that's a trade-off because often when you buy low quality materials, you need more labor to install them, which then balances out the cost, and or you end up with quality issues, which is a different part of that triangle. So use less material, buy larger quantities, buy cheaper materials, and then finally is labor. Labor is generally the biggest portion of the cost for most things. Skilled labor isn't cheap. Cheap labor isn't skilled. That's true most of the time. But some of the time, the cheaper the labor is just because living expenses are cheaper. So the labor costs here is a lot different than the labor costs on, say, Martha's Vineyard, because there's basically no living wage on Martha's Vineyard. Nobody can afford to pay you enough to live there. So the labor expenses there are much more expensive. And it doesn't have anything to do with the quality of the labor, just where they live. Which is why, again, the prefabrication helps because you can choose where your factory is and therefore how much that labor might cost as a base level. And it's also why some people are actually moving factories to Canada because they have that whole healthcare thing, which lowers the cost for each individual employee quite considerably. So, cheap labor. And then faster. Everybody wants to build faster. And We live in New England, so we know about the whole weather thing, and it makes it hard to build in the winter. As you may or may not notice, it's dark at, 4:10. That means that you aren't going to be working 12-hour days at this time of year, even if you could stand the cold, because it gets dark and it's a lot harder to do a lot of things in the dark. So cold, weather, dark, lots of reasons why building gets slower in the winter or just in bad weather in general, which is why prefabricated is going to be, in some senses, better. Then there's the whole repetition. As you can see, there's that really cool factory that looks like it's going to do a million different pieces at the same time. That only works if you have a system that can handle doing the same kinds of pieces. If not all the walls are the same height, if not all the windows are the same type, if you're not using the same materials, then that factory system doesn't work. You have to have some things that are repetitive, whether it's the size of the wall or the type of materials you're using. So it does make it faster. Henry Foard showed us that. It's faster if you do them all the same. But architects in the room probably realize that nobody likes it if everything is the same. So, and then there's quality, more gooder. So precision, craftsmanship. It can be done by hand in the field. A lot of people think it's easier to do when you're in a factory. That is really about the people. It's about the people doing it. Guy in the factory can do just as bad a job as the guy out in the field, or just as good a job. So it's about how many people are overseeing it, how easy is it to do, that makes that craftsmanship come in. And then there's energy efficiency and durability, which mostly have to do with design, which is why better really comes down to design. It's about the materials you choose. That's the environmental part of it. If you look at the two suburbs up on the top there, one is better for the environment than the other, but they're both very repetitive. They're doing the same thing over and over again. So they're trying to get that bulk pricing thing going. But that's all about the design of it. It's not about whether they built it off-site or on-site. It's about what they chose to build in the first place. And then the surface area to volume or surface area to floor area ratio. Just this past fall, I had to teach an architect who was complaining that we'd quoted a job for them before and it was $60 a square foot, and now we were at $120 a square foot. And I had to explain to him that he was building, the first one was a box with 2 floors and flat ceilings, and the second one had a roof line that literally went, and we're like, yeah, you have a lot more surface area. That's why it costs more per square foot to build. And she was like, why didn't you tell me that to begin with? And I was like, why didn't I tell you that to begin with? Is it my job to tell you that? Apparently it is. So yes, surface area matters for how much it costs, how fast it is to build, how good it is for the environment. It matters. And then we're back to that whole repetitive thing. Architects love creative curves. That's why we've got that bottom apartment plan versus the top apartment plan. This one down below looks a lot more interesting, but it's going to be more expensive to build. Basically because the builder is going to look at that plan and go, okay, how am I going to do that? And the architect's going to say, I don't know, you figure it out. And then they'll go through another few phases of design, they'll get an engineer involved, they'll get somebody else involved, and eventually they'll be able to build the curvy one. But it's not going to be cheap, it's not going to be fast, and it might not be very environmentally sound either. Who knows? And the last one is about how much design you have to do. There's an awful lot of plans out there, generic plans, general plans, modular plans, that really they didn't finish the design at all. They didn't do the structural design, they didn't figure out where they're putting the electrical, they didn't figure out, how is the plumbing supposed to make a 1/4 inch pitch from this bathroom over here to that over there where it's draining out, especially if you have a really thin floor deck. So for a long time, architects have basically been leaving that to the guy in the field to figure out, to the general contractor, to the whatever. Somebody else has to figure that out, which is fine, except for that sometimes you need to know just enough so that you know that you have to leave enough floor deck space so that you can do that plumbing layout. Or you need to know a little bit to know what materials you can spec and what you can't. You know, a 30 by 40 open plan living room is really hard to do out of wood beams and wood joists. You can do it if you have like a 20-inch deep deck, but most people are thinking, oh no, 12 inches is plenty. And then you have to go to steel beams, which are more expensive, generally. So how much design do you need to do? And prefabrication and modular design forces you to do more of that thinking up front. So, this is another piece of better that most people don't think about. Only one of those pictures is OSHA approved, but there's a second one that's probably okay. The one that's the biggest, that really, really is sketchy, and hopefully none of you are asked to do something like that. But there are plenty of people who still build with very sketchy setups, because yeah, it's cheaper and faster if they do it that way. So that's safety, and it's a lot easier to be safe if you have a controlled environment than if you are doing stuff where you need to be up on ladders and going up to a second floor that isn't built yet and stuff like that. And then appealing jobs. So carpenters are getting old. Average age is 50, which means not enough of you people out here want to become carpenters. Most of you don't want that job. And it's true. If it's out in the cold and the wind and it's hard work, it's less appealing. It's more fun if you have a stable job that you don't have to travel 2 hours for every day, and you can work 9 to 5 or 6 to 2:30, which is what our guys do. Whatever it is, it's a set level. It's available there in the summer. It's available in the winter, which isn't always true around here for construction jobs. It's really hard to plan your life if you don't know if you're going to have a job in January. So appealing jobs. I think, honestly, that this is the biggest reason that we need to go to prefabrication. It's because we need people who want to build, and it's not a fun job if you don't know if you're going to have it, and if it's cold and wet and miserable and dangerous. So that's the biggest better. And then, because I am so interested in the environment, better for the environment. There are lots of different reasons and ways to be better for the environment. I think that this thing in yellow is the most important thing, and it's the one that gets forgotten. It cannot be built to be disposable. Buildings have too much energy in them, no matter how you build them, to be disposable, which means you have to decide to build it to last 100 years, to last 200 years. You know, buildings in Europe aren't intended to last 20 years and then be thrown away. That's why they're more expensive, but it's also why they have buildings that are 1,000 years old. So don't design something that you don't think will last. And then sustainability and prefabrication, they aren't always the same. That top right-hand corner is a straw bale house being plastered. Straw bale is unlikely to be prefabricated. It's not likely to be happening, but it is very sustainable. So that could be a choice if you are going to put sustainability higher than economics or any other design decisions. The one on the bottom right, they are trying very hard to be durable and energy efficient. So it could also be under the sustainable and long-lasting, and that's prefabricated. But you don't have to build really well to be prefabricated. So they aren't mutually exclusive, but they also don't always overlap. So summary, in case I went really long, but it is a lot of different things for building better, and you aren't going to get all of them, so you're going to have to choose which ones are most important to you and how to weigh which one versus the other. Is prefabricated better? Not always. In fact, a lot of the time, currently, it's not. because a lot of the time they're focused on cheaper and not necessarily on better. So. Faster. Is it faster? Depends how you count your time. It's almost always better, or faster rather, to install time for if you prefabricate things. Almost always it's faster to put it together on the field to install it. But a lot of that extra time that you're saving on the install is coming from your manufacturing time, and it's coming in your design time. You're doing a lot more of that design thinking up front so that the guy in the field doesn't have to figure out where the plumbing's going, because it's already figured out. So he doesn't have to spend that time out in the field. It got done somewhere else. Obviously, these charts are entirely made up, so don't think about the proportions, because I just made that up. The idea is there, though, because we get a lot of complaints about the design time we're adding to this project when we get a set of architectural plans and then we have to turn them into shop drawings. It adds time, but we're also figuring things out like the structure and where you're going to put stuff and how it's going together, which then saves you time in the field. So, is it faster? I usually say yes, because usually when people are talking about faster, they're talking about install time. The overall time from when the client says, I want to build a house, to the time they're moved into that house, it might not be faster. Depends. And then faster or cheaper. You can always just pay for more people and build it faster. It's up to you. And then, again, can't say it enough, design. Design is always what's going to make it cheaper or not cheaper, which is why all the people who are doing design need to get good at doing estimates for themselves, doing takeoffs, thinking about, well, how much surface area in this? How many things am I doing that are different than what I did in the last job? And if you want to invent a detail, which I know because I love inventing details, there's a lot of architects who like to play with the details, especially the new sustainability students. They want to think of a better way to do it. That's great. Keep thinking of new ideas. But don't just send them out without asking somebody who's actually built something if it's doable. Or if it's expensive to do it that way. Because sometimes they'll say, yeah, that's really hard to do. I could do it, but it's really hard to do. And some things they'll say, no, that looks pretty good. I can do that. So ask somebody, and ask somebody who knows something about the system that you are building in. So don't ask the concrete guy about the panelized, the stick wall work, and don't ask the stick wall person about the concrete work, because we don't know how hard or easy it is for that concrete guy to build that extra pocket for that beam or whatever else it is you're trying to do. And then, again, use less materials. It should be obvious, but it's not. And it's also really hard to do while exercising your creativity, because nobody actually wants to live in the 6x6 cube. That would be super efficient. And then structural and mechanical design. I spend a lot of time doing the structural design on architectural drawings because SIPs are a different structural system, and so they can't just rely on the builder, or rather we are the builder, to figure it out. We have to actually, what size joists am I using? What size ridge beam am I using? All this. And I run into a lot of people and architects and stuff who just don't have any common sense or just any sense at all of how to build things and how much space it takes to put the structure in, which is frustrating because I don't want to screw up the design that they built. I don't want to tell them that they can't have that room that they want. But if we build it the way they want it, it's going to be expensive. And they also don't want that. So there's a lot of thinking about that needs to go into it. What is it built? How is it built? Who's building it? And design it and then build it. Because no matter how much more time and how much more expensive it is to design it, it's cheaper to change the computer screen than it is to rebuild it. So it is cheaper. Usually, weather delays, you can reuse scraps in a manufacturing facility in a way you can't on site because you don't have enough jobs there, so you can't reuse a scrap that isn't going into that job, whereas in a manufacturing, I can reuse a scrap from this job on that job over there. It encourages energy efficient designs or material efficient designs, but they aren't always. Panelized houses can be just as big and convoluted as any other design. And then better coordination between utilities, which basically means, have you talked to the plumber or the electrician beforehand? Because it makes it a lot cheaper if they aren't looking at it and going, I don't know how I'm going to do that. So, and if you talk to the same electrician all the time, then they get familiar with the way you're doing something, and they're less likely to upcharge for, I don't know how to do that. But conventional is also cheaper. Conventional relies on the know-how of the builder, and therefore they don't need as much design time. That is cheaper. If the guy on the field knows how to do it and you don't have to spend the time designing it, it can be cheaper that way. The big one is shipping, obviously. Big pieces, especially with modulars, you're shipping a lot of air. Apparently the Chinese ship modulars with televisions in them to use up all that space, which, sure, that works. We don't do it that way, so it's just empty inside usually. And then weather protection of pieces of the building is like an extra step and extra materials, which means that if you don't have to do that, it can be cheaper than if you're only weather tightening the building once rather than weather tightening it for transportation and then weather tightening again when you're done. And again, back to the structure. Sometimes you need extra structure to install a modular or a panelized thing that you wouldn't need if it was just being built on site. Better? Again, maybe, maybe not. I go back to appealing job, definitely. That one wins. Prefabricated is usually better. Transporting only the materials you need to the site. On-site waste goes directly to a landfill. In a manufacturing facility, a lot of it still goes to the landfill, but some of it gets reused. Most of the others, a little bit here, maybe, maybe not. I would say joints between the pieces, which is on the maybe not. It's sometimes harder to join up two big pieces than a bunch of little pieces where you can put a continuous thing over the whole assembly when it's done. So now we're back to the connections. How many connections are you making? If you're doing a modular that's only two pieces, you only really have that one connection around the perimeter, and then you have to connect it to the ground and to the plumbing and the electric and the water. That's simpler, but you still have to think about the protection of the piece that's separate from the other piece. That inside doesn't want to get wet. There's an awful lot of modular companies that get called back because the drywall was all ruined because it rained before they got the install in, and they have to re-drywall the whole thing, and that doesn't save you any time or money. So, joints. How are you going to air seal it between the two parts? Or the many parts if you're doing a panelized? Is it watertight? Is it connection structural? How are you connecting utilities? Panelized has a lot fewer companies that put in utilities just because there are so many connections. And if you're going to have to tie together your wires at every single panel, it's sometimes cheaper to just do it after the fact. In fact, it's usually cheaper to just do it after the fact. And then that brick joint, is it pretty? Does it look good when you connect those two pieces of finish with a weird little accordion thing? Sometimes. Sometimes that's high enough on a building that they don't care. But sometimes people do care about things like that. I don't know why. And fewer joints. Fewer joints is usually better. Less materials, less time on site, fewer pieces to mess up your quality control when you're putting it together on site. But again, the weather protection of the whole piece, that can be pretty hard. You're building a ceiling and then another floor on top, but that ceiling still has to be just as weather tight as the final ceiling at the very top, at least for the week or two that it's going to be out in the rain. And it might be that it'll be out in the rain for 3 months because construction schedules are notoriously irregular. They don't go where they were intending to go. Even if you're faster, it's still going to have delays, things that you didn't expect. And so it's going to be out in the weather, and it's going to be out in the wind, and it's going to be wet. So, yeah. My experience is all with SIPs. So we're going to go into details with SIPs because that's the only one that I really know the details about. All the rest of them, I've only got hearsay. So SIPs are oriented strand board, OSB, glue, and foam, which is super simple. They are a structural system in that the OSB is the structure. It's what's actually holding this thing up, which means you can't cut a million holes in it without it falling down. And it's also insulation. Obviously, the foam is insulation. But again, the foam is part of the structure, so you can't cut out all the foam and still have it stand up. So. The advantages and disadvantages of SIPs are they're not finished. We don't even try to do any weather sealing of the building. We don't put in windows. We don't do any of the interior finish work. And there's lots of little pieces, small to medium sizes. They get transported easily because we can just do 4x8 stacks or 4x12 stacks or 8x24 stacks of pieces. But that means there's more pieces to put together. So no utilities. We do occasionally do wire chases, but no actual wires or any of the other utilities are actually in the panel. So all of that gets site built. And it's easy to hybrid with other systems. We mostly don't do SIP panel floors. They get built conventionally out of I-joists or 2x or whatever else. So, and sometimes you do hybrids with timber frames, and sometimes you do hybrids with conventional stick frame roofs. So all sorts of things. Plans. So we start with a 3D model, and then we make shop drawings. This particular project, Foard panel got because we were the only one that said yes when the architect showed the Rhino model and had no 2D drawings at all. And we built it, and it's standing up, and it's a very cool piece of sculpture. But yes, it takes a lot of design to go from the 3D model to the building pieces that you're going to cut and put together to make that. That building is an observatory. There's not a single plumb wall in the thing. And yes, that was not cheap and not sustainable, but it's really cool. So manufacturing. Foard panel is not one of the cool high-tech manufacturing places with all the CNC machines and the mechanical lifts and wall systems. We keep trying, but they cost a lot of money, and so we haven't quite got there yet. So the big machine is the laminator. Puts glue on sheet goods, and then we press them together. The middle row, let's see if I can use that. These are vacuum bags. So the vacuum bag comes down over the panels after the glue's been put on it. They pull a vacuum, and that's what presses it to keep the glue tight. The glue is basically Gorilla Glue, only it's the commercial version. So very, very good at making things stick. Once we have a pile of panels, we use old-fashioned tools, really, really big routers and really big saws and hand labor to lay them out and cut them. And yes, we would much rather have a CNC machine that does it, but we have been in the process of designing said machine for 2 years now and have not yet gotten a machine that A, cost within our range, and B, could do half of the things that a guy with a saw can do. So we're working on that. And then, of course, that's the most common way they get shipped out. It's in bundles of panels. But we do also sometimes prefabricate walls. We'd be putting together a bunch of these pieces, putting all the blocking in, cutting all the windows, that kind of thing. And occasionally, we do the tiny houses for full mobile home people who want really small buildings. So that's the manufacturing as Foard panel does it. There are SIP manufacturers that A, have the CNC machines And there are some that do a lot more prefabrication than we do sometimes. But mostly that's because many of the other manufacturers don't have install crews. So they're sending out just the package, and therefore their installers would prefer if they put more of the stuff in, whereas we do a lot of the install ourselves, so it's actually faster and easier for us to sometimes do it in the field. So that's where it comes to install. Yes, we are out in the field, in the snow, all winter long. A house that, like this one, that's like a 4-week job. It's faster than stick building that same house, but not that much faster. Because you still are stick building all the floor decks, and you're still putting each of those pieces together in the field. So, faster, sort of. And then joints. SIP panels, their biggest claim to fame is the minimal thermal bridging. So the common joint is a spline joint. There are 2 splines made out of plywood. And then the middle channel here gets filled with spray foam as their air sealing. It's really good for thermal performance. It's actually really good at air sealing. But again, we're not attempting to do any kind of weather tighting. I get a fair few calls from people who have this wonderful SIP building they put up, and then it rains, and water is coming in. And they're like, is it ruining it? Is it broken? And I'm like, no, it's airtight, not watertight. They're 2 different things. And yes, if water can get in, air can also get in, but it's about the quantities. And generally, a bucket full of water is nowhere near ACH1. It's a very small amount of actual material going through that joint. So, yes, they are airtight, but definitely not watertight. So, and again, no utilities. Hard to do. So here's some specific joints for anybody who is interested in architecture details. Spline joint, I-joist joint. The I-joist joint gives it more strength without giving up too much of the thermal performance. And then the one, oops, sorry, wrong one. This detail with the small post and the spline on the outside, that only works if you have a really thick panel. If you're doing a 6.5-inch wall panel, the post is going to be the full depth of the wall panel. So I stole these slides from the Passive House presentation, so they're the exciting details for people who are building with thick walls. So roof details, big long screws, putting together the pieces with big long screws. There is a foam joint up there, which basically means we cut it wider so that you can spray foam in between, and that's the air sealing joint. And then the structural joint is, again, the screws down into the ridge beam below, or you can do it with rafters, but only if they're really close together. Generally in all like timber frame, we want there still to be some little connection piece at the top so that the 2 roof panels don't deflect versus one versus the other. And basically the same thing. These are rakes and those are eaves, but basically a 2x in the top of the wall and you screw down into it, which is very familiar for most carpenters, so it's not that crazy, except for that you have to buy the big screws. That's a deck detail. The one on the left is a typical detail. The one on the right is, again, the Passive House if you have thicker walls. If you don't have a thick enough wall, you're going to be stuck with the first one. Beam pockets. Panels are really strong, but they're not magic. If you have a giant beam, you're going to need a post under it. Ridge beams, floor beams, stuff like that. Foundation details. There are so many foundation details. This is like 0.1% of how many foundation details there are. But basically, it works like any other foundation. You have to attach to the foundation with a PT sill or plate of some kind. The one on the far end there, that's timber frames. It only works because there is a timber frame there that's holding all the gravity. Otherwise, that panel is not handling any gravity load. Otherwise, it would have to be on the foundation and not sticking off like that. So are SIPs cheaper? Not really. The materials are definitely more expensive than your conventional building materials. Even EPS is more expensive than a fiberglass, and that's the cheapest option we've got right now. But they are less than doing steel and spray foam, so sometimes they're cheaper. Labor costs. Again, this is about where is it being installed. We do a lot of work on Martha's Vineyard, again, because their local labor is really expensive, so it's cheaper for them to pay for our guys to come and have hotel rooms and waste 4 hours on Monday and on Friday as they travel there. It's still cheaper for them that way. That's the labor cost thing. On the other hand, in the middle of nowhere, Vermont or Massachusetts, sometimes it's cheaper for them to just hire the local guys because they don't have the overhead we have, and they don't have to travel, and they can do it just as well. So generally, it comes out we're about the same as a conventional system at the same performance, which means a 2x6 wall with fiberglass bats is going to be a lot cheaper than a 6.5-inch EPS panel. But the 6.5-inch EPS panel will be about the same as that same fiberglass wall with the 2 inches of XPS on the outside, which would have a similar performance level. So same at the same performance, occasionally cheaper depending on the labor, not usually cheaper. Is it faster? More design time? Fewer pieces than a 2x6 stud wall? Structure, insulation, and air sealing in one step, which is nice. But you're still doing a lot of work in the field. So it may be faster, but it's not going to be months faster. It's going to be weeks faster for most scales of jobs. It depends on the scale, obviously. Yeah, weather. We have some weather coming in. We have a lot of jobs that are going to be delayed. It happens all the time. Unfortunately, that's the way it is. So, better quality. Craftsmanship, we have consistent quality control, but it still comes down to the guy in the field doing the work. And some days they have good days and some days they don't. So we have mistakes and we fix them. And quality materials. Again, we have quality control procedures that they have to follow. Doesn't mean it's perfect. Yes, they are definitely energy efficient. Long-term durability. No, it totally depends on who's designing it and who's doing the finished detailing. Those two pictures on the right, those are both SIP panels, SIP houses. The one on the middle there, here, let's see if I can actually make that work. That clearly was not the way you wanted to detail it. The water is clearly having come down from the corners of the windows, therefore the flashing detailing, which was done by somebody else, was not done well. The house here, this is our paranoid engineer's house. He spent a lot of time teaching the guy in the field to do the details he wanted them to do, to strap out and to do metal flashing and triple layering his tar paper flashing around the windows. And I have pretty good confidence that's going to last a while. Obviously, it's only been built for 3 years, so we have no real proof of that. So we'll see. And then better quality, environmentally sound. It's all about the design. This little house right here, that's very efficient. This ski area, base lodge, that's not so efficient. It's very pretty, but no, it's not going to be more efficient. So, yes, more appealing. Only on the manufacturing side. We struggle to get people to want to work on our install teams. They leave at Monday morning at 6 a.m. and they get back at Friday at 6 p.m. They live at a hotel room all week, and they are traveling all year round. And yeah, some guys really like that. Some not so much. And especially as they get older and have wives and children, they want to be home for the soccer game. They want to be able to come home in the middle of the week. And so yeah, the install, we want more people, and some people like that job, but no, mostly not. And environment. We're pretty good with our waste management, but it's made out of foam. It's EPS or polyiso, and I can't argue that that's environmentally sound necessarily. So, safe for workers? Usually. We try pretty hard. I would not say we're 100% OSHA certified all the time, but we try. And don't think we've had any major injuries, so at least that's good. Maybe, maybe not. This is basically just a review of everything I just said, so I'm not going to read it aloud to you. It's mostly in case somebody wanted this after I was done. Overall, so this is, again, not just panels, SIP panels. Faster to install, yes. More appealing job, yes. Easier to quality control, at least for the prefabricated parts. Parts you have to do in the field, those can still be screwed up pretty easy. And it encourages repetitive designs, which are cheaper. It doesn't always have them, but it encourages that. And quality better, that's totally up in the air. Depends on who's doing it. So, back to our original triangle. We've now made it a 5-sided shape, but you still can only choose 4. So, which ones you choose and how you choose to implement them, up to you. Up to the designer, up to the client, up to the person with the wallet, because often it comes down to cheaper. So that's where you're trying to think about it. And this room is full of people who I'm hoping someday will start trying to find new details and new panelized systems that are a better mix of those 4 or 5 choices. I spoke really fast. We are now early. Feel free to ask questions.
So before we get to the questions, though,
Yeah.
I have to say that Alison's candor about what the realities are in her company and on the site in this construction world were especially refreshing. Because often when the presenters are here, they're speaking from perhaps not through rose-colored glasses, but at least through trying to project a position of superiority and comfort, that their way is the best way.
I did not wear my Foard panel shirt today intentionally because I was like, wow, I'm here I'm speaking for panels, but I am also here trying to be for the people who are learning, and it's not 100% rosy for Foard panel or panels in general.
A pleasure.
Thank you.
And the coveted BCT water bottle.
Nice.